So in short, CUDA makes few guarantees about when and where thread blocks will run. And this is actually a huge advantage for CUDA. This is one of the big reasons why GPU programs can go so fast. Why is that? So among the advantages that the GPU gains from this programming model is that the hardware can run things really efficiently because it has so much flexibility. For example, if one thread block completes quickly, the SM can immediately schedule another thread block without waiting for any others to complete. But the biggest advantage is scalability. Okay, because you've made no guarantees about where the thread blocks will run or how many thread blocks might be running at a time, that means that you can scale all the way down to a GPU that would be running with a single SM, something that you might find in a tablet or a cell phone, all the way up to the massive GPUs that are used in supercomputers. Importantly, the scalability also applies to future GPUs. So you can be sure that GPUs will get more and more SMs as Moore's Law gives us more and more transistors on a chip, and by writing the code in such a way that it can run on an arbitrary number of SMs and doesn't depend on a certain number of SMs, a certain number of thread blocks being resident at a time, you can be sure that your CUDA code will scale forward to larger and larger GPUs. So this scalability applies from cell phones to supercomputers, from current to future GPUs. And that's a really huge advantage. And there are also consequences to this programming model, which are the things we've been talking about. You can make no assumptions about what blocks will run on what SM, and you can't have any explicit communication between blocks. For example, if block X is waiting for block Y to give it some result before it can proceed, but block Y has already run to completion and exited, then you're going to be in a bad place. That, by the way, is an example of something called deadlock in parallel computing. This really means that threads and blocks must complete. Okay, you can't simply have a thread that hangs around forever, processing input or doing something, because that thread must complete in order for the block that it's in to complete so that other threads and blocks can get scheduled onto that SM.